Today I discuss protolysis of water and pH under hydrogen ion concentration. What is protolysis of water? Water undergoes protolysis, that is dissociation, to give H plus and OH ion, and the liberated proton, that is H plus ion, immediately join water molecule to form hydronium ions, H3O plus, and conventionally simple H plus is often used to represent H3O plus. That means that H plus is actually H3O plus hydronium ion. So from the law of mass action at equilibrium, for this equation H2O to H plus plus OH minus, then this is found, and water being the acid, as it liberates H plus, Ka is the acid dissociation constant of water at given temperature, and this bracketed items, bracketed terms, represent the molar concentration, mole per liter, of the respective substance at equilibrium. That is bracketed H plus is the molar concentration, that is mole per liter of hydrogen ion at equilibrium. So from this equation we get this, that is Kw. Kw is the ion product or the dissociation constant of water at a given temperature. The value Kw at ordinary room temperature, that is 25 degrees centigrade, is 10 to the power minus 14 molar. Pure water, each water molecule, for pure water, each water molecule dissociates into one H plus and one OH minus ion. Hence, this is equal amount, that is the number of for pure water, number of H plus ion is equals to number of OH minus ions. So we can change this OH minus to H plus ion, so we get this. And as we know that Kw for pure water is 10 to the power minus 14 molar, so H plus concentration is 10 to the power minus 7 molar. Hence, solution with H plus concentration is 10 to the power minus 7 molar are said to be neutral. If H plus concentration is greater than 10 to the power minus 7, are said to be acidic, and if the H plus concentration is less than 10 to the power minus 7, are said to be basic. So the value of H plus concentration for most of the physiological solution, for example our blood sample, have near neutrality and are inconveniently small and difficult to compare. As the physiological solution, the H plus value is so small and very near of each other, so it is very difficult to compare. So a more practical quantity of determining this H plus concentration or the to express the acidity was devised in 1909 by a Danish chemist Søren Sørensen is known as pH. pH is the negative logarithm of H plus concentration to the base 10 when H plus concentration is expressed in mole per liter. So pH is equal to negative logarithm of H plus concentration. So for pure water or neutral aqueous solution at room temperature, that is 25 degrees centigrade, we know that H plus concentration is equal to 10 to the power minus 7 molar. So pH is equal to 10 to the power minus logarithm 10 to the power minus 7 is equal to 7. So Sorensen's pH scale is a logarithmic scale ranging from 0 to 14, where pH 7 is considered the neutral pH. If pH is less than 7, is said to be acidic, and if pH of a solution is greater than 7, is said to be basic. So we can remember that for 1 molar solution of strong acid, pH is equal to 0. For 1 molar solution of strong base, pH is equal to 14. And if two solutions differ in pH by 1 unit, they differ in H plus concentration by a factor of 10. Now we are going to solve some problem related to this pH. So the problem 1 is how many H plus ions and OH minus ions are present in 250 ml of a solution of pH 3. So we use these two equations to determine the H plus ion concentration and OH minus ion concentration. So first of all, as we use equation 1, that is pH is equal to minus logarithm of H plus concentration. The pH is 3, so I use it here, 3. So H plus concentration would be 10 to the power minus 3 molar. So molar, we know that molar is equals to mole per liter. Now, so we know if a solution of 1 molar contains 6.023 into 10 to the power 23 ions. Therefore, ten to the power 10 to the power minus 3 molar contains 6.023 into 10 to the power 20 ions. Okay, we multiply 10 to the power minus 3 with this, so we get 6.023. into 10 to the power 23 ions. So as we've seen that 10 to the power minus 3 molar is, that means at 10 to the power minus 3 mole per liter, that means this much ion is present in 1 liter. So 1 liter contains 6.023 into 10 to the power 20 ions. Then for 250 ml contains 6.023 to 10 to the power 20 by 4. No, 250 is 1/4 of 1 liter. So the answer is 1.506 into 10 to the power 20 ions of H plus. So we got the first portion of this problem, that is the H plus ion present in 250 ml of a solution of pH 3 is 1.506 is equal to 10 to the power 20. And now we identify OH minus ion presence. So we use equation number 2, that is H plus ion concentration and OH minus ion concentration is equal to 10 to the power minus 14. So if I take log of both sides, negative log of both sides, then negative logarithm H plus concentration minus negative log of OH minus concentration is equal to 14. That means pH plus pOH is equal to 14. So we know that pH is 3 from this equation. pH is 3, therefore pOH is equal to 11. So if pOH is equal to 11, then OH minus concentration is equal to 10 to the power minus 11 molar. That is mole or gram ion or gram ion, mole per liter or gram ion per liter. So from here we know that 1 molar solution contains 6.023 into 10 to the power 23 ions. So 10 to the power minus 11 contain 6.023 into 10 to the power 12, right? Ions. So this means 1 liter contains this much ion, therefore 250 ml contains 1.506 506 into 10 to the power 12 times of OH minus. So this is our answer. Another problem. Calculate the pH of the following solution. So we're going to solve this problem. And here also we use these two equations. Equation 1 and equation 2. So for A, that is for 0.002 molar HCl, strong acid HCl. So for this, H plus concentration is 0.002 molar. So we have to identify the pH. So pH is equal to minus log of H plus concentration so this is 2.699. If you going to use calculator, if you do not use to calculate, then you may use this. We omit negative sign by changing this. Log 1000. Then log 2 we have to know the value 0.301. For the if any exam competitive exam we do not use, they do not permit to use scientific calculator. That's why you have to know the value of log 0, log 1, log 2 to log 9 if possible. Otherwise you have to calculate like that. For log 2 you use the value of log 2 and calculate the same. And for B, solution B, we have to identify the pH of sodium hydroxide, a strong base. So here also, you know, OH minus concentration is given 0.015 molar. So we have to identify, we have to use here equation number 2. So H plus concentration will be 10 to the power minus 14 by 5. Okay. So this is 6.67 into 10 to the power minus 13 H plus concentration. So pH will be minus log of this. So pH is 12.18. As I know that, and in our next video we will solve the problem of other two.